Okay, so I went ahead, cut the other side and this back edge here, and so now we're going to come in and trim that last part off. And I set the stop on the X axis so I don't overshoot it, like I did on the feeding in the Y direction over here a little bit. So let's continue on, and okay, so both of those are trimmed off, and so we've got a couple more things to do on this. We gotta part that off, and on the edge here we gotta come in from the other end and drill and tap a hole for a set screw. Alright, so let's get this parted off and see how that goes. This is going to be a highly interrupted cut, as you can see, so let's hope for the best here. Okay, so as you can see, we still got quite a bit to go here, so I'll just keep picking at that, and I'll bring you back in a little while. Wow, I'm pretty surprised how uneventful that really was. So let me go fish it out of the chip pan here, and we'll check it out. Alright, so that went exceptionally well. I did not expect this to work out as good as that. So this is a couple of thou over the finished 5/30 seconds. I think this is 162 thousandths, 161 thousandths thick. And let's see here. Zero that guy out and see what we got here. So, you guys can see it's 162. We were shooting for I believe 156. So how critical that is, I don't really think that's an issue, but probably just put some wet dry sandpaper on the surface plate, clean it up, and we'll see what we could do with that. this finish here could get a little nicer too. So other than that, I could make the crankshaft, put it in. There's a set screw that's got to go in there, and I guess I could put this back in I could put it back in the lathe and just take a face and cut off that. That might be the best option. So all right, let's get this back in the mill, and we'll get a hole drill down in there with a tap, and that'll be for the set screw. I think that's a 256. We'll check out the plans and bring you back over by the mill. Alright, so what we gotta do now is gotta drill a hole down the edge of the crank, and that's for a set screw that's gonna lock up against the crankshaft itself. So that's got to be indexed correctly for the timing of the engine. So that's got to be pretty much spot on 180 degrees from the crank pin here, which is located here. So I came up with this idea so that we could locate this accurately and be able to drill down through the edge of this and not come in at the side or at an angle, because that will in turn throw off the valve timing. So let's get you over by the vise on the mill and show you the idea I came up with. Alright, let me lower the radio here, because I'm not redoing this video. So I got it set up, and what I did was I just took two parallels, and before I did this I made sure there was no burrs on the inside of those cutouts. So what I did was I just slide everything in here. I just used two parallels to support this, pushed down on it, locked it down in the vise, and I think that's reasonably accurate for this. And then of course now I used my little center finder here and moved the table back and forth until that was centered over there. So the table is locked in the x-axis now, and what I'll go ahead and do is get an edge finder and pick up the edge of the back here and come in half to 5/32, which is 5/64, and that'll put that on the center here, and I'll drill and tap that for a number 256 set screw, which is I think a number 50 drill bit. So let's get going with that. Let's get an edge finder in here. Hundred thousandths. And now 5/64. 71 thousandths. So I'll go in 71 thousandths now. Just check my chart again, 78 thousandths. Right there, we'll lock things down. backwash out a little bit. Alright. Let me get this out. I'll get my center drill in there. And we'll do the deed here. That looks about right. So let's put some touch of Earl on there. Let's slow this down a little bit. I'm going to switch out drill bits. That just doesn't seem to be cutting. So once again, let me get another drill bit and we'll continue with this. Alright, so let's get this thing drilled. That's much better. Oh, come to think about it, I think I had problems drilling a number 50 not too long ago for something else. So I'm going to throw that drill bit right in the garbage, and I'll add that to my shopping list next time I head over to the store. Alright, so just thinking this out a little bit more, rather than try to tap this whole length here, which is quite a bit, with a little 256 tap, I'm going to drill down about 100 thousandths, which is not quite halfway, with I think that's a number 44 drill bit, and that diameter will be just a little bit larger than the outside of the 256 tap, so that'll give me clearance, so I won't have to run the tap through all of that material. So let's go. We'll get that guy going. So now we can get tapping without further ado. Alright, so coming down to the final operations on this here. Okay. Alright, then that should do it for this piece. with the exception of just maybe facing that a little bit after I make the crankshaft itself. So alright, this is going to wrap it up for today, and hope to see you guys back soon as we continue on this little Elmer's engine. I forgot what number it is. The number 3 open column engine, I think it is.